In this video, I'm going to be talking about the AMC7135 drivers, which output a constant current of 350 milliamps, which is perfect for driving a lot of diodes commonly found inside DVD burners. Before you take apart your DVD drive though, it is important to look up the model number and figure out exactly what kind of DVD drive it is. If that drive is only capable of reading DVD drives and not writing to them, there's a high chance that you end up with a really weak laser diode, which is not at all capable of high power outputs. So you have to make sure that your drive is capable of writing to DVD drives, and the write speed is also important. A DVD drive that has a write speed of 8x is going to have a weaker diode compared to a DVD drive that has a write speed of 22x. Personally, I have a laser diode from an 8x DVD burner inside of this housing, and I can confirm that it's capable of lighting matches on fire, burning through electrical tape, and you can also make out the beam at night. But you'll have a much more powerful diode if you take it out of a DVD drive with higher write speeds. So here's the schematic you're gonna have to use to create a driver with the AMC7135. Before you connect the diode to the driver, you're gonna have to figure out its polarity. Now, most diodes manufactured in this form factor are going to have their positive pin at the top and the negative in the middle when you hold the diode in this orientation. If you take a close look, the negative pin is merged with the casing of the diode. With a multimeter in continuity mode, you can connect the negative probe to the casing of the diode and then touch all of the other pins with the positive probe. When you get the polarity right, you should see a faint red glow coming out of the diode. If you don't see that, you either have the wrong pin or you're dealing with an infrared diode, which is used for reading and writing to CDs instead of the red one. So you can also use a multimeter to identify the infrared diode and the red diode in your drive. Now, in some cases, you're gonna find diodes that look completely different in your DVD drive. If you have a diode that looks something like this, in my opinion, it is ideal to leave it in the heatsink present inside of your DVD drive and just sand it down until it fits in the housing. Because if you remove it from the heatsink, you're most likely going to end up with something that looks like this. This is a different diode that I got from a laptop DVD. And the problem with this is, while you can attach it to the housing, it is very difficult to thermally connect these to the housing compared to simply shoving the entire heatsink inside the housing like I've done here. To mount this guy, I used some thermal paste, and once it was pushed into the housing, I used some super glue to hold it in place. It's a lot more ideal if you end up with one of these diodes which fit perfectly into those housings, but you're not always going to be lucky. So in the event that you run into one of these, I think it's a lot more ideal to just shove the entire heatsink that they already are attached to inside of your housing instead of taking them out. This is how I wired the AMC7135 to the laser diode. I'm using a tiny ceramic capacitor that I salvaged from an old board. I measured it with a multimeter, and this is around 0.3 microfarads, and it works perfectly fine. And I've connected the negative wire to the pad on the back of the AMC7135 instead of the pin because it's a lot easier that way. Now, if you find one of these diodes, it's going to sit at the perfect distance from the collimating lens, so you're not going to have any issues with focusing it. But in my case, the diode is further back from the lens because of the heatsink. So I had to remove the silver thingy to be able to push the collimating lens further down. With this thing on there, the collimating lens was sitting way too far away from the laser diode, and so it wasn't able to focus it at a distance. Now, these rings are screwed really tight to the rest of the lens, so I had to use a pair of pliers to separate it from the rest of it. But once that was done, I was able to screw this guy in a lot closer to the diode, which allows me to focus it properly. And I'm powering the entire thing with a single 18650 cell. Keep in mind that once you have installed your laser diode into this housing, the entire housing is going to be electrically connected to the negative of the laser diode, which is why I decided to mount the push button on the battery holder instead. Alright, I'm gonna turn off the light, adjust the focus. Now keep in mind these laser diodes are extremely dangerous. Ideally, I can't even recommend powering them on without appropriate safety goggles. I'm going to be looking at this through the camera with you guys. I'm afraid the tiny spot this guy is going to create on the electric tape might be enough to damage my eyesight, so better to be careful. Okay, I think I have it in focus. And as you can see, electric tape is no problem for this guy. Let's try a match. That's a lot of fun. And one more. The beam quality on these guys is absolutely insane. They're capable of focusing the light to a really tiny spot, because that's necessary for reading and writing DVDs, which is why they're so good at burning things, since they can focus a lot of energy into a really tiny spot. Anyways, that's going to be it for this video. Make sure you take the necessary precautions when you're using one of these diodes, and I'll see you in the next one.